my luck will be better. So this session is moving your Silverlight phone applications to Windows 8. So I'm assuming a few things about the audience here, that you know a little something about Silverlight or XAML. Could be a WPF, could be desktop Silverlight, could be phone Silverlight, just some XAML language. And that you're interested in how that might turn out on the new Metro. I'm John Waters, working for Office Software. We have the mobile conferencing app that you hopefully have been using, EventBoard. And that runs actually on all three major mobile platforms. I wrote the Windows Phone 7 version of it, and so after I went to build, I got really excited about trying to move that to Metro to see how much actually carries over and what you end up having to redo. So this talk is kind of my experience from that process. This isn't really a deep dive into Windows 8. There's a lot of content about Windows 8 available from the Build conference online, if you look at the Channel 9 videos. And there's a lot to learn, and I can talk about Windows 8 forever. So you will see some Windows 8, but it's not going to be the kind of focus of the talk. I've been using this actually as my work PC, Windows 8, now for a week, and it's actually been really nice. It's been fast. It's been faster than Windows 7. I like it. The issues I had today with external output, I did not experience at home or in the office. You guys got unlucky. So for an alpha, looking pretty good. Obviously, things are going to happen today. So one of the things with Windows 8, the current build, is you can't actually run the Windows Phone 7 emulator virtual machine under Windows 8. So I provided some screenshots for you instead. This is our mobile phone UI on a Windows Phone. And some of the things you can see are, we have this overview page with current conferences. Here's the code camp right here. We're actually going to be able to be as live in my phone as well. And this is a typical Windows Phone control. So there's not much space. We can only fit 3 conferences in here. And then there's an All tab to show the rest of the conferences. And that uses the pivot control. If I drill down into the app and look at my sessions, I've got sessions by day, so on Saturday, Sunday, and then again I can only show a few sessions here because of the limited real estate. Here's how the favorites look. Remember this little favorites icon here, so you can see that again. So on the phone UI, you're kind of constrained to what you can fit into it. This is the Metro version of EventBoard. It's one of the screens, and I'll show you some other ones too. But you can see for sure that it's a different ballgame, right? Because you've got this a much larger screen to play around with. And so even if you manage to bring over all of your code and get through my tips and tricks to get it to compile on Metro, you don't necessarily want to bring over that phone UI. You want to have this show up on your tablet. It's going to look really odd to have something like 3 sessions on the small screen. So if for nothing else, the tablet format is going to require that you rewrite the view of your application. And it goes deeper than just because of the format, also because there's some unique capabilities in Metro that don't exist on the phone, and some intrinsic controls and integration to the operating system. Those are things that you want to take advantage of. So it's not a Win8 deep dive, but I do want to mention a little bit something about the background of this. So what we're looking at here is called a Metro style application. The Windows 8 has kind of a dual personality. It's got this Metro subsystem, which is over on the left, and it's got the desktop app system, which is on the right. The right-hand side is more like your Windows 7, your desktop. It feels just like Windows 7, I think. It's got some facelift, it's a little faster. The right-hand side is a new beast to us. And you can develop your code in all kinds of different ways. If you're a XAML developer, you can continue to do XAML development with C# or VB. And it looks and feels just like Silverlight desktop development or phone development. C and C++ are now first-class citizens. You can actually develop XAML apps in C++ as well. And then there's a whole new way here of using HTML5 and JavaScript. no matter which one of these you choose, you have access to what's called the WinRT, Windows Runtime APIs. And really what it is just it's a set of C++ classes with a interface. And they've taken extreme pains to make this interface look extremely natural for a .NET developer. So for the most part, it's hidden so well that you can take your regular programming style and bring it over to Metro style development, and you might not even notice that a whole lot has changed. There'll be some new APIs and new capabilities. There'll be some new data types in a few places, but they've done a very good job of making stuff the same. So in fact, across all these different XAML platforms, what's at the bottom is very different. The actual underpinnings is very different on the phone, desktop, Windows 8. But on the surface, it's very similar. So XAML and C# and class libraries are very, very similar. So it's an easy transition. So if you look at the task from an MVVM standpoint, you've got your model, your view model, and your view. The model here is really just your entity classes. So in EventBoard, things like sessions and speakers and rooms. There's nothing platform specific about those. You can just compile them under Windows 8. And there's some options. There's something called a portable library, which is an assembly that can run across multiple .NET platforms. But you're constrained to using a subset of the functionality of all the platforms that's available on every platform. Another option which I used is you can just go into Visual Studio 11 and create a new assembly and link in your class files from your desktop application. So when you go File, Add Existing Item, and you choose the existing model files, there's a little button that says Add as Link. So now it's pointing to the old file, it's not copying it anywhere. And since everything in those files works equally well on Windows 8, it just compiles. You're done. If that doesn't make sense, I can show you what I'm talking about here. Here's the project. You can see that, for instance, here's a file here called constants, and it's just full of constants. There's nothing Windows 8 or Metro specific about constants. If I go up to the top of my file, it's just a namespace with constants in it. There's no if-defs, there's nothing Win8 about it. And as you can see here, this is just a link to my constants file that comes from my phone project. So that part of the port is trivial. When it comes to your view model, the view model is a multifaceted beast. How many people here are using MVVM? So there's kind of a model-facing part of the view model, and there's a view-facing part of the view model. The part of the view model makes your model useful for binding to the UI. Just things like the arrays notify property changed. Part of it is maybe an abstraction of your application, so you can use it to perform business logic. Like in the EventBoard case, there's a bunch of logic that knows how to hit our cloud service, powers all the OData feeds that are all the different sessions and speakers, take that XAML, convert it into model instances. That's all in the application view model. And so all of this stuff has to do with application logic, and the model just goes straight over with a few tips and tricks. The stuff that's to support the view might go over if the view stays the same. But the view in Metro requires some new things to assist it. There's a new GridView that knows how to group things, which I'll be showing you. And so you have to expose some kind of data that implements a groupable interface so that control can bind to it. So that was a new requirement of Metro, so you're going to need some new stuff in your view model. And then finally, your view, there's really not much to bring over from your view because it's so different tablet form factor. I was able to bring over things like styling, so that little heart I showed you. bringing over that and using the heart on the metro side is easy. But in general, your application layout, you don't want to bring it over.
So if you're using any like Silverlight toolkit stuff that you cannot bring into.
Yeah, so you have some dependencies to libraries like the toolkit, and in our case we're using Flickr.net, we're using Maps, and those things are not quite available yet on this platform, so you're going to have to wait until there's something there. If it's on Codeplex, maybe you can be brave and download the source and try to get it to work yourself, but it's so early now that when it comes to external dependencies, it's probably a good idea to just wait a bit until someone else has taken that hit. I'm sure there'll be a toolkit version for Windows Metro pretty soon. So the view model, I'm running a bit late here, but there's just a ton of ways to bridge differences between the platforms. The shared files approach, I think, is the easiest to get going, especially if you want to support your code on both platforms and not abandon the old one. So now you've got to maintain code on two platforms, so you don't want to have two sets of files. You want to have one set and just hide the differences with additional defines. Some other techniques I'll show you are you can use interfaces to abstract out things that are similar in capabilities but implemented differently on different platforms. So like persistent storage, state management, showing messages in the UI, all that kind of thing. Create an interface for that and implement different versions of it. You can use polymorphism. It's an object-oriented language you're working in, so you can have a base class and then you can have override certain methods that are specific to your platform. You can use extension methods to add in methods that are missing or change their signatures so they look like they used to look. So let's look at some of these ideas. And then after this, I'm going to look at some of the specifics of what you can use in Windows 8 that makes it Windows 8 better. So here are some of the problems I ran into. Namespaces, it's kind of trivial, but a lot of stuff is moved just to a new place. And there's lots of logs online that show you what's mapped and where, and you can just do it with some additional defines. There's some important type differences that you just have to change your code with ifdefs again. There's some interesting threading changes that we'll talk more about, and there's this new await async keyword in C#, which is amazing, which we'll talk about. So let's just dive into some of these. So here's an example of the whole technique with using additional defines. So I've defined a Win8 symbol. If it's Win8, I'm using Windows.ui.laml. If it's not, I'm using system.windows. Pretty much everything moved from one place to another. So if you look at this code, there's no, except for here, there is no specific Windows 8 code. But the fact is that the definition of property changed event handler and the definition of identify property changed, these things have changed to different types in a different namespace that happen to have the same names as the old ones. So if you just change the namespace and compile, it works. That's it. If you don't change the namespace and compile, it still works because these old namespaces still exist. So it compiles, and then when you run it, it doesn't work because data binding doesn't work at all using the old namespace types. So if you wonder why is nothing showing up, it's because you forgot to do that namespace translation. The other gotcha here is that in my Windows Phone code, I had dependency object as my base class for my view model classes. And the reason I had that was because many times in Windows Phone asynchronous programming, you set off a background task like an HTTP web request download, and it returns on that background thread. And then you want to update a property that the UI is bound to. If you do that from a background thread, then you get an exception. You need to switch to the UI thread with dispatcher being invoked. And a handy way to get hold of that dispatcher in Windows Phone is to use the one that's inherited from the dependency object. Well, there's a known bug in Metro right now, so if you inherit from the dependency object, compile it runs, but binding just doesn't work. I spent a long night and said, well, what's wrong with this? It doesn't work. And finally, I found the blog. It's like, yeah, it doesn't work. It's going to be fixed. And so some of these workarounds, if you're early like me now, you'll be banging your head against stuff, but this will just be fixed. There'll be refreshes. There'll be new versions of the development preview, and these things will be taken care of. But right now, you can't inherit from dependency object. So that's fine. I'll just comment it out. But I had it there for a reason, right? So I wanted to be able to switch back to the UI thread inside of my view model. So I need to get the dispatcher from somewhere else. So what I did is I just added a property to my object that's a dispatcher, and I set that dispatcher from when I instantiate my application view model, I take the current Windows dispatcher and stuff it in that property, and then I have access to the dispatcher again. One interesting thing about Metro is you don't actually need to switch to the UI thread that often, because if you're using a way to sync, many times your operations that you start out, even though they're not blocking the UI, they automatically return on the UI thread for you. So you don't have to do this, check if you're on the UI thread, switch back to it stuff. So most of the cases where I needed to call dispatcher to begin invoke are actually redundant. And so in a way, the fact that it's no longer there isn't a problem, and when I've got everything completely moved over, it won't be a problem either. But it's a good example of the if-def approach. Dispatcher.begin invoke changed its signature. It's actually called invoke async now. But all my code uses begin invoke. So here's how you can use an extension method. You just define a static method inside of a static class, and where this parameter is this kind of type that you're extending. So what I get in here is a core dispatcher and an action to perform, and then I just call dispatcher invoke async with this action.invoke. So it's just a trick that will make your code look like it hasn't changed. I can still call dispatcher begin invoke because I've added in this method. So here's an example of me setting this all up. I create my view model, I set this dispatcher property, and go. Another pattern example here is state. So when you switch between pages on the phone, you can save state, and you do that using phone application service.current.state, which is a dictionary of string and object. While on the Windows 8 Metro, you have state as well, but it's application data.current.local service.values. It's a completely different thing. This happens to be an iProperty set, which happens to be a dictionary of string object. So this is a dictionary string object, and this is a dictionary string object. So I just defined an interface called iStateHelper. iStateHelper just has a state property, and then what I do is on the one platform, my implementation does this, on the other platform, my implementation does that. And I just set this all up. Here. So this is kind of my homegrown dependency injection. I just have a static class that I call my dependency container. And it just has some properties. It has a state helper property. To that, I assign a new Metro state helper. If we look at the Metro state helper, that's my guy there that uses application data.current.values. On my phone, same code assigns a new phone state helper that does the other one. So at runtime, I just kind of inject the correct implementation into my dependency container, and then I use that within the application. And that way, I've hidden the difference behind the interface. Okay. How many people have seen a little something about await async? Do you like it? Did you see Andrew's talk on that? Pretty good talk. You see that, Bruno?
Yeah, a little bit of that. What we're doing with sync is great. Asynchronous calling.
So, you phone developers, how many people actually write phone apps? Because you know that everything on the network is asynchronous, and so you always have this continuation code. You fire something off, and then you pass, there's different ways of doing it, but you end up with another chunk of code that takes care of the result. And many times you do this in multiple layers. You've got EventBoard, we have this chain of like 20 calls deep, where each call iterates through an OData and fetches pages of OData. So it's just this huge blob of code. Where do you put your exception handling in that? I mean, there's a good place to put it. Application unhandled error. I wonder what was going on. So let me show you some code here that is pretty neat. Can you read this? Is that readable? Okay. This is the code that goes and fetches a bunch of different things. So each of these little things here I'm loading session times, here I'm loading session types, here I'm loading resources and vendors and sponsorship levels, all these different things. Each of these is an OData call, which in effect is a web request. What am I doing? I've got a list of tasks here. Task is something that started out in the task parallel library in the full.NET framework. And it's become kind of the container to use for awaiting background things. So I've got a list of tasks, and it looks like I'm adding method calls to this list of tasks, right? It looks like I'm calling a method here. And then when I've done adding all of these things to my list, I'm doing await tasks when all, and passing in this list of tasks. So what this is doing is it's performing all of these tasks pretty much at the same time. It's not technically performing them in parallel, but all of these are going to block on the web request at some point. And as they block, then something else can be done. So another piece of code can be running on this thread. So what it manages to do is it manages to fire on all of these tasks in quick succession, and then it's waiting for them all to return. And this await all, or when all, is not going to, the code is not going to continue until this line, until all of this is finished. So if these tasks take about the same time, then I maybe sped this up factor 10. As it turns out, some of these things take a long time to load, and some of them take no time to load. And so it ends up being that long one that bounds the total processing time. So it doesn't end up being 20 times faster, it ends up being about twice as fast. But okay, it's twice as fast, but look, it's readable. I can read this code. I see what's going on here. If you look at my code that's doing this asynchronously without await async, it is a mess. And I can put a try except block around this and handle exceptions. Just simply and elegantly. So I get it. It's faster, it's readable, it's got structured exception handling. What's the catch?
It's not in Windows Phone 7?
There's a CTP for it.
Oh, there is?
Yeah. That is the catch. So once you've seen this stuff, you get spoiled. And let me just dig down a bit deeper into what's going on here. Let's look at this one call. It has this new keyword async, and it returns a task. Normally a task returns a task, an async method returns a task of t, where t is whatever the thing is you want back from your call. If you don't want anything back from your call, i.e. it's a void, then you just have a task. And so actually all of these methods that fetch data, they don't return the data back to me, they put it in my application view model. So I don't need to return anything. So it's basically saying this is a void. Why does it say async? Well, it says async here because I am calling await in here, one level down. And I cannot await something unless I am awaitable as well. So it kind of bubbles up the call stack. Because I want to wait for this call, then I have to be declared as asynchronous. And what am I doing here? When I'm calling my OData fetcher and passing URI, I'm getting back a list of entities, which is an IEnumerable of OData entry, and then I'm parsing those out. So let's go look at this guy. This is calling down to another await. So now I'm going to 4 levels into my awaiting. And here's where the actual fetching does. So this call takes the URI and downloads an X document. You can see there's another await going on in there. Let's go into that. So here's my actual, this is my HTTP client, get async. There's my innermost await, and you can see that all the way up, that signature is bubbling up. I'm switching to the HTTP client because it implements this interface. The old HTTP web request works, but it implements the old kind of asynchronous processing. So it's not all that useful in this context. One of the other things you'll see with this approach is, here's my entity fetch loop. It awaits download of a document. It parses out the contents, and then down here, I look at the end of the document to see if there's a link to the next page of my OData data feed. And if there is, I need to go fetch that page. So I'm just setting the URI, and then it goes back to the top here, and this is a do while loop. So see do while. So I keep going until I don't have a next page. So now I've actually got a do while, or repeat until loop, which is really asynchronous. But it doesn't look asynchronous anymore. It looks like a regular loop. If you were to try and implement this without a wait sync, you just get fragments of code spread out. So, needless to say, a wait sync is very good, and you need to figure out how to use it, because it just makes things easier. One problem I find with wait sync is it's only for methods. So if you in your code have a getter that's supposed to fetch something, and that getter ends up calling something asynchronous, there's no such thing as an asynchronous property get. And my view model has quite a bit of that. For instance, it checks whether a conference is already cached on the phone, in which case it gets it from the phone rather than downloading it again. And there's just a getter that checks in local storage to see if the conference is there. Well, I can't check in local storage on Windows 8 synchronously. It's an asynchronous call. So my getter can't be implemented using that API. And that's really, it'd be great if the language had an asynchronous get, and if the language had an asynchronous interface, but it doesn't. So you have to rethink your solution. You have to check these asynchronous things and have them calculated before you need them with non-getter code. So what I do is I download the list of all the conferences, and if I'm not online, I have my previous list of all the conferences that I had. I loop through all of those and check local storage to see if I have all of the data, and then I create a little dictionary that has for each conference a flag saying, yes, I have it, no, I don't, yes, I have it, I don't. And then I change my getter to look into this dictionary so I don't have to look into async storage, and that way I got around it. So you'll find some things like that break your code when you start going with a new way to sync, as soon as you end up in a getter. Oh, we're doing time.
Once the lunch next, you can go as long as you want.
Yeah, I started pretty late, so if I'm not caught on this thing.
It's 11:30.
11:30.
Oh, good. Goes to 12. Okay, so here's some other things. The collection view source. Who uses the collection view source? It's changed. Collection view source used to do sorting, used to do filtering, grouping. It doesn't. The idea now is you use link. You use a link query to do all of that work for you. So this is in the Metro version. I'm taking all of my sessions, I'm grouping them by a property I added called grouping order, which can be by track or by time slot, into a group. And then each of these groups gets the key, and it gets the items in that group. So this builds up a group, of, a list of sessions grouped by track. That's what I need to bind to. That's what I bind my collection view source to. And then the controls that understand grouping, they can now group that data in the UI. Sadly, right now, link group interfaces are not compatible with collection view source group interfaces. So link implements, I forget which way around it is, groupable, and the UI controls use grouping. So they're not the same interface. So, hence this code that then iterates over my group and puts them in another collection that implements the right interface. This will also go away. This is no problem. The teams are working together. You will be able to just bind your link straight to your framework element and not have to worry about this trick. At the very end, I've got my collection view source and setting the source to the groups, and I'm done. So things have disappeared completely from the collection view source because you're supposed to be using link instead, which is fine. We talked a bit about this. There's a bunch of minor things you run into when you convert your code. Things have disappeared. Regex options not compiled no longer exists. High value converter and some other things have changed a bit. New resource formats. Some HTTP utilities isn't around anymore. You don't close streams, you do using statements. I'll show you some of these guys. This is kind of a trivial thing, the I-value converter. Instead of a strongly typed target type and a strongly typed culture info, it's got two strings. Most converters don't touch those parameters. So I just a conditional define to define them differently, the code doesn't really change. There's a new format, so this is my favorites heart. To reference that file inside of an image tag, I have to use this new format here, MS resource, and then here's the assembly, and then you have to have files here, and then images is my directory here. So that's a new construct. Not that hard to change to. Network connectivity on the phone. You can do network interface, get is network available, and you can also check the network interface type, make sure that it's a valid type. The Metro platform has a really interesting interface for network connectivity. It has a concept of connection profiles, and you can request a specific profile, the get internet connection profile, or you can enumerate all the available profiles. So say you've got, like on this cabinet, it has actually AT&T wireless connectivity, and it has Wi-Fi connectivity, and I might plug it into my docking station that might have wired connectivity. So each of those is a connectivity profile. And not only can I tell whether that particular profile is connected or not, I can also ask about the cost and the bandwidth. So I can say, how fast is this connection? Is it free? And you can make intelligent decisions in your application based on that, which of these things, okay, I'm on the free high bandwidth connection, I'm in the office. Okay, I'll download a bunch of data now. Or, I'm on